Okay, we're going to look at multiples, factors, and divisibility and how these are all connected. So the first thing, a multiple. This is just a number that's multiplied by itself over and over. So 7, okay, multiple of 7, so multiple again is 14, it's 21, it's 28, it's 35, etc. So these are your times tables. These are the numbers that early on at school you would have done the counting of these, counting by 2s, by 3s, by 5s, by 7s. And these are all just multiples, okay? And they form the basis for what then became your times table. Let's have a look now at factors. All right, factors are numbers that divide evenly into another number. So for example, what number goes into 12? Well, we know that 1 times 12 is 12, so 12 goes into that once, and we know that 1 goes into a 12. So 1 and 12 are definitely factors of 12. What other numbers go into 12? Well, we know that 2 times 6 gives us 12, so 6 goes into 12 evenly twice, and 2 goes into 12 evenly 6 times. So 2 and 6 are also factors. And then we know that 3 and 4, 3 times 4 gives us 12, 4 goes into 12 evenly 3 times, and 3 goes into 12 evenly 4 times. So 3 and 4. So these are all the factors of 12, but when we write them, we need to write them in ascending order, like this. So the factors of 12 are here 1, 2, 3, 4, 6, and 12. And we can do this for any number that has any number, and some of them will be prime numbers where there's only 2 factors, and others will be really factor-rich numbers like 12, like 24, like 36. Okay, divisibility is deciding if a number will divide into another number. So for example, if we take the number like 25 and we go, is 5 divisible into 25? Well, we know that 5, 10, 15, 20, 25. So we know that 25 is a multiple of 5, so therefore 5 must go into it, okay? If we look at, say, 7, does 7 go into 25? 7, 14, 21, 28. It's not one of the multiples of 7, so 7's not divisible into 25. We want to now look, though, at simpler ways of working this out, and so we're going to look now at divisibility tests. Okay, so for each of our numbers, we can apply some sort of visibility test to it. So if we want to see if an even number is divisible by 2, we just have to see whether it's even to start with. So all even numbers end in either 0, 2, 4, 6, or 8. So if we look at these examples, is 24 divisible by 2? It ends in a 4, so yes it is. 25 ends in a 5, it's not one of our numbers here, so no, it won't be divisible by 2. Here, 26 is even, ends in a 6, so therefore it is divisible by 2. 27 is odd, doesn't end in one of our given numbers, so no, 2 won't be divisible into that. Divisibility test for 3 will be that the digits sum to a multiple of 3. So that'll be 3, 6, or 9. So if we look at the example here of 18, 18 is 1 plus 8, and that gives us, 1 plus 8 gives us 9, so yes, divisible by 3. 24 is 2 plus 4, and that's going to equal 6. 6 is one of our multiples of 3, so yes, divisible by 3. 31 is 3 plus 1 equals 4. It's not one of our multiples of 3, so 31 is not divisible by 3. This is quite handy with some of those larger numbers you might come across. So for example, if you're given, say, a number like 124, okay, and we know that 24 is divisible by 3, but now if we look at this, it's 1 plus 2 plus 4, it's going to give us an answer of 7, so 124 not divisible by 3, okay. But we see here that 7 is only 1 away from 6. So if we went down by 1, 123, it's going to give us 1 plus 2 plus 3 equals 6. So we can use that knowledge to manipulate it if there was a problem-solving question saying, if you had to change this digit here, what would you change it to make it a multiple of 3? Okay, now the number 4 is interesting because with the number 4, we really only have to, we don't have to consider the last 2 digits. And the reason for that is if we take any other number, so let's take a large number, okay, let's say like 2,348, okay? Now, if we look at this bit here, the 23, that in actual fact is the number 2300, or 23 times 100, okay? Now what we know is that the number 4 goes into the number 125 times, okay? So we know that any hundreds or beyond, they're multiples of 100, so 4 automatically goes into them. So what that means is we can disregard that in terms of its divisibility because we know it's true, and we just need to consider these numbers, these last two, the tens and units numbers. Okay, so in this case, we're looking for, are they multiples of 4? And of course, 4 12s are 48. So yes, 4 will go into 2,348. 5's one of the easier ones because the last digit is either a 0 or a 5. So 1,355, we just have to look here and we go, yes, that's going to be divisible by 5. 1,263, 3 is not a 0 or 5, so that's going to be a no, not divisible by 5. Okay, now we're looking at the number 6, and the number 6 has two parts to it, okay? Firstly, it has to be an even number, okay? And then if it is an even number, is it then divisible by 3? Now we know from previously that divisible by 3 means we add the sum of the digits together, it'll give us a multiple of 3. So here, for example, we have 1 plus 2 plus 0, and that's going to give us 3. So that's a multiple of 3. And it's even because it ends in a 0. So that's a yes, 120 divisible by 6. Here though, we have 1 plus 2 plus 7 gives us 9, which is also divisible by 3, but it's an odd number. So this one would be a no. Okay, for the number 8, it's a little bit tricky, okay? It takes its lead from our divisibility of 4. With divisibility of 4, it was the last 2 digits. With number 8, it's the last 3 digits. And the reason for that is that 8 times 125 will give us 1,000. So any multiple of 1,000, like here, is automatically going to be divisible by 8. So we can not worry about that 3 in this one. We want to look at just the last 3 numbers here, and we want to see, does 8 go into those, okay? And so what I would say, I'd look at this and go, well, 8 goes into 24, okay, 3 times. So 8 goes into 240, 30 times. So it goes into 240 plus 1 more 8, so it's going to be 31. So yes, 8 goes into 248, so therefore 8 goes into 3,248. Okay, so let's have a look at divisible by 9. In this case, we want to sum the digits together. It's got to be divisible by 9. So 2 plus 7 equals 9, so that's a yes. 36, so 3 plus 6 is going to equal 9, so that's a yes. And here we have 342, so 3 plus 4 plus 2, 3 and 4 is 7, and 2 is 9, so that's also a yes. 10's probably the easiest one, certainly easy as 5, ends in a 0, so 300, yes, 428, no. Simple as that, just looking at that last digit here, and clearly if it ends in a 0, it's divisible by 10, it's also therefore divisible by 5, it's also an even number, so it's definitely divisible by 2. So sometimes you get multiple from just the one idea. Okay, now 7 is the only one that's not on our list, and really the only way of doing divisibility with 7 is to just use multiples of 7 times 10, 70 is probably the easiest strategy. So if we think of the number 70, and we look at the number we're given, in this case it's 427, so let's think how many 70s go into, say, 420, and we know that there's going to be 6, and so we've got a 7 left over, and 7 will go into that, so it'll go in 61. 61 times 7 will give us 427. If we're just given a random number, let's say 895, what I would say for something like that is I would say look at that and go, well, 700 is definitely a multiple of 7, so you're left with then 195. I'd then look at 2 lots of 70, which is 140, so I'd take away 140, and that would leave me therefore with 55, and then 7 into 55 doesn't go, okay, because 7 8s are 56. So no, 895, not a multiple of 7. So a little bit more work to do with the 7, but it is a way of working it out without having to do necessarily this scenario in order to find it out. But to be honest, sometimes that might be the easiest strategy for you to use. So good luck with that.